Hello everyone, welcome back to the course Infrastructure Asset Management. This course is offered under MOOCs, an initiative of Government of India. In the last lecture, we started our discussion around Infrastructure Asset Management framework and we briefly discussed about the role of data. In this particular lecture, we will be focusing on data requirements for infrastructure asset management. If you remember, in the last class, we had seen this generic infrastructure asset management process, which started with data collection and then we moved towards performance modeling, understanding development of alternatives and so on. Now, this week the focus will be on data collection. We will dive deeper into understanding the different aspects of data collection. Within data collection, we need to understand that there are different categories of data. We saw this in the last lecture that information needs to be collected for different aspects like organizational focus, the condition of the assets, total cost and so on. Now, I will discuss each of these in detail in this particular lecture. Let us start with understanding what information needs to be collected as far as organizational focus is concerned. For this lecture, I will be using examples of either an institute building, say some student hostels, or I will use the case of roads. Now, let us assume we are an agency which needs to maintain their national highways. Now, data requirements as far as organizational focus is concerned involves four things. One is the vision of the organization, second is the mission, third is goals and finally fourth is objectives. Every organization has some vision. It is a long term idea of what the organization wants to achieve. For example, in case of roads or highways, the agency might have a vision that they want to create safe, efficient and sustainable road infrastructure while ensuring connectivity and supporting socio-economic development. As you see here, this is an overarching idea. They want to ensure that the roads are safe, efficient, sustainable and they promote connectivity and socio-economic development. Like any vision statement, this is a long-term goal. However, from an agency's point of view, they need to understand that what is the specific mission and then what are the more short-term and near-term goals. So, based on the vision statement, they prepare mission statement. Mission statement looks something like this. For example, they can have a mission statement which says they want to enhance access to remote or underserved regions to promote economic integration and social inclusion. Another mission could be around safety. They want improved road safety through better design, enforcement, education and technology. Around sustainability and environment, they could say we want to adopt environment friendly practices in road construction and maintenance. I hope the idea is clear that the mission is generally derived from the vision. Now, the mission statements are aligned with the vision statement. However, still they are pretty broad. Thus, the agency tries to set up specific goals. Goals around the mission statement will look something like this. They want to achieve zero accidents on road. They want timely proactive maintenance of road segments, or they want to achieve net zero goals or carbon neutral condition. So, you can see here that goals are more finite and they are very easy to interpret. They are more specific so that all the stakeholders in the organization are aligned with these goals. Finally, based on these goals, the organization sets specific objectives. So, for example, for around safety, objective could be that they want to significantly reduce traffic fatalities and serious injuries in the next 2 years. You see, there is a time component here. They have a more concrete objective which they want to achieve in the next 2 years. This objective will help them in reaching the goal of zero accidents on roads, which will help them in improving road safety through better design and also ensuring that they provide a safe environment. So, I hope the idea is clear that the specific objectives which are selected by an organization are a function of the vision and the mission of the organization. Similar to safety, there can be objectives around roads performance. They can say that we want at least 90% of highways should be in good condition by the end of next year. So, this is a more specific goal around the road condition. Similarly, they could say that we want to reduce carbon footprint of the road infrastructure by 20%. As you see here, objectives are more time driven as well as specific. Now, when we start discussing about infrastructure asset management, we need to understand what is the vision of the organization and we need to collect relevant data around it. So, the first part of data collection includes understanding the vision, the mission, specific goals and objectives, because we want to ensure that whatever decision we take should align with the organization requirements. So, enough information needs to be collected to make a better understanding of the organization's objectives. Now, we have understood that we need to understand the organizational focus of the organization. Next is condition assessment. We want to assess the current condition of assets. Before we move to current condition, there is one more step in between, which is around understanding the inventory of assets. Inventory of assets is a collection of all the information about existing assets. Here, the idea is to understand how many assets does the organization own, what types of assets are available, what was the cost of procuring or constructing these assets, what is the current value of these assets, as well as what was the maintenance plan for these assets. Before we do any decision making, we need to understand what is the inventory of assets. Inventory of assets basically is a collection of all the assets which the organization owns. Now, once we know that what are the assets available, we need to assess its condition. Let us discuss what are the data requirements around condition assessment. The question is, what needs to be assessed or measured to understand the condition of the asset? Here, we rely on both primary and secondary data. So, for example, if I ask you that how would you assess condition of a hostel building, I tell you that you can go and record information about different aspects. What all aspects would you cover? Think about it before looking into the answer. I hope all of us have come up with some parameters which could be used to assess the condition of buildings. I believe a lot of you are thinking around these lines where you would say we will try to see cracks, leakages, honeycombing. We will also try to use methods like rebound hammer value or the ultrasonic pulse velocity value. You might say we will look into dampness, or if there is any spalling of concrete. You can also say we will look into wall bulging, sagging of roofs and so on. So, these are just some of the methods which could be used to assess the condition of a building. The idea is these are the primary set of data. This is the information which will be collected by looking or observing the infrastructure. Now, in addition to primary data, there is some secondary data which can also be used to make an assessment of the current condition of an infrastructure. Secondary data includes age of the infrastructure. You want to know how old an infrastructure is. Then the expected life of an infrastructure. You want to understand that when an infrastructure was designed, what was the expected life of that infrastructure. Next, you might want to see the frequency of complaints which are raised by the users. You also want to look at the technical and operational data, past data of maintenance and rehabilitation on the infrastructure. Similarly, you might want to do a questionnaire survey, or you want to understand the general sentiment of the users. Also, you would want to look into the past reports of visual assessments, as well as you want to understand the demographic data to understand the vulnerable population as well as the vulnerable infrastructure. Vulnerable infrastructure is a function of the environmental conditions. So, you want to understand whether a particular infrastructure is subjected to excessive harsh weather. So, these are secondary data sources. The idea is that in addition to the primary data which can be collected on site, we also collect some of the other relevant information which helps us in decision making. It is around age, expected life, frequency, operational aspects, the general sentiments, past reports, demographic data, and so on. So, I hope the idea is clear. Primary data is the information which is collected directly on the site. Secondary data includes some of the other aspects which could be not measured directly, but still can be assessed with the help of surveys, questionnaires, or by analyzing past reports. Now, I will discuss some of the ways to collect some of these information. Different methods for data collection include visual inspections, photographic surveys, non-destructive testing, structural health monitoring, environmental quality assessment, physical assessment, functionality assessment, component failure modeling, and partial destructive testing. I am sure if you have taken some courses in structural engineering or structural analysis, you have learned about a lot of these methods. In this course, we will not get into the details of these methods. The idea is that some of these methods are available which can be used for data collection. Now, we have an understanding of how to assess the current condition of an infrastructure. We need to collect relevant information around it. After this, we need to understand what are the data requirements around model assumptions or model development. Now, in order to develop a model, we need to assume some parameters. To assume those parameters, again we need to collect some relevant data. In case of model development, we have seen that any infrastructure will typically follow a performance curve which looks something like this. If time is on the x axis and performance is on the y axis, we have seen that when we do not do any maintenance, the performance tend to decrease with time. Now, as far as asset management is concerned, we need to understand the characteristic of this curve. We need a method to actually estimate how performance will vary over time. To do that, we again have to rely on data collection. We want to understand the relevant data which can be used to predict the performance of an infrastructure over time. Let us look into what type of data is required for developing a performance model. We can start with age, where we want to know what is the current age of the infrastructure and how does age play a role in performance deterioration. The idea here is that any new infrastructure will deteriorate slowly, but an infrastructure which is old will deteriorate at a faster rate. Then we want to assess the technology of construction or the build quality. What we are trying to say here is that if the technology of construction was good, if the build quality was high, the initial performance level P will be higher, and also the rate of deterioration will be low. So, if the build quality or the construction quality is good, then we can expect that the deterioration will be slower. Next is weather conditions. In order to estimate how performance will vary with time, we also try to understand what are the weather conditions. Under an extreme harsh weather, deterioration will be higher. However, if there is a weather which is favorable for the infrastructure, the deterioration will be lower. So, again we need to collect data around this. Then the next aspect is occupancy. If an infrastructure is used at 100% occupancy, then it will have a different deterioration rate than if it is used at 50% occupancy. Also, if a building is overused and the occupancy levels are higher than 100%, then one could assume that the deterioration will be higher. So, we want to understand what is the occupancy levels of an infrastructure, so that we can use this information to predict the performance of an infrastructure. Then we also want to know what is the frequency of maintenance. Also, we want to understand what are the physical damages, what is the type of damage. The information about building material used will help us in assessing the expected life of an infrastructure or a building, because the expected life or the remaining life is a function of the building material used. Finally, in addition to weather conditions, we also try to understand if there is any exposure to natural or man-made calamities. This also helps us in performance modeling. The whole idea here is that we need to assess how performance will vary over time. In order to do that, we still need to collect some data. In this slide, I have discussed some of the information which can be collected for performance modeling. In addition to these, there are some more information which, if available, can help us in performance modeling. These are as follows. We want to understand what is the level of biodeterioration. If there is any chemical attack on the infrastructure, we want to assess that. We also want to understand the structural integrity of the asset. Also, we want to know what was the strategy of planning used during the construction and how effective is the asset management which is being carried out. So, all this becomes a part of information collection. This helps us in developing the performance model for an asset. So, till now we have discussed what are the data requirements for understanding the focus of the organization. We have also understood what is the information or data that needs to be collected to understand the current condition of an asset. Then we saw that we need to make some model assumptions for performance modeling. So, we discussed what data needs to be collected for model development. Now, we will move to the next step, where we want to understand what data needs to be collected around maintenance techniques and their costs. The idea here is that in order to prepare an asset management plan for an infrastructure, we need to first develop an understanding of what are the available maintenance techniques and what is the associated cost. So, the data which needs to be collected here is as follows. Data requirements for maintenance techniques includes information which might look something like this. Here, this information is presented in the form of a graph. I will try to explain this to you one by one. You can see that on the x axis we have time and on the y axis we have the payment condition. This is a representation for a typical road where the pavement condition is measured using condition score. Here we can see that for this particular road segment, the minimum condition threshold is given here. Let us assume that the condition scores are on a range of 0 to 100, then initially the condition is 100 and we could say that the agency does not want the condition to go below 30. Now, as far as maintenance techniques are concerned, we have different options. First one is no maintenance. We could say we will not do any maintenance. The second is preventive maintenance, where you say that we will do some maintenance to extend the life of the roads. Third could be light rehabilitation or medium rehabilitation, and then last could be heavy rehabilitation or reconstruction. So, we need to understand what are the maintenance techniques available to us. However, this information is not enough. In addition to the type of maintenance technique, we also want to know the associated cost with them. So, if you see here, there is zero cost associated with no maintenance. Say for preventive maintenance, the cost is around $37,000 per unit lane mile. For light rehabilitation, it is around $2,20,000 and so on. So, now we have information of the cost associated with each maintenance technique. In addition to this, we also want to have an idea of how performance will vary if a particular maintenance is carried out. So, if I go back to this model, we had seen that performance goes down with time. However, if you do maintenance in between, the performance can increase and then again go down. It can again increase and go down. So, you can see this information represented here. So, for example, if you see this particular pavement section here, you can see that at this point, if I do preventive maintenance, the performance will increase by a factor. It will go up by this amount and then it will start to deteriorate like this. Here you see that the information of how much increase in performance can be assumed is given. So, the number 3 here represents that if I do preventive maintenance, the condition of road will improve by 3 units. So, for example, if the original condition of a pavement is 75 and I do preventive maintenance on it, then the new condition will be 75 plus 3, which is equals to 78. So, for any maintenance technique, we want to know what is the cost associated with it and what is the expected performance. Now, if I follow this curve and say that let us assume we did not do any preventive maintenance here, we allowed the infrastructure to deteriorate. So, if I do not do any maintenance here, the infrastructure will deteriorate a lot, say it gets deteriorated till this point. Now, since we cannot allow our infrastructure to go below the threshold, we will need to do a heavy rehabilitation because the infrastructure has deteriorated a lot. Now, obviously, the cost of performing a heavy rehabilitation will be higher than other maintenance techniques. However, based on the type of infrastructure, if it has deteriorated a lot, we may or may not see a very high rise in the performance. Generally, it is believed that the cost of not doing any maintenance on time is very high because most of the time either it is not possible to do heavy rehabilitation or even if it is possible to do a heavy rehabilitation or reconstruction, it is very costly. Thus, it is preferred that we do preventive maintenance on time. So, you could see that if we had done preventive maintenance here, the infrastructure would have deteriorated like this. Make a note here that at a given time t here, if there is no preventive maintenance done, then the performance has decreased significantly. However, if we are doing preventive maintenance on time, we can prevent the payment from deteriorating at a higher rate. However, still it will deteriorate by some number. Now here we could see that there might be a point somewhere down the line where we might want to do a light rehabilitation, or if we do not do any light rehabilitation, the performance might even go down and we might be required to do a medium rehabilitation. So, for any infrastructure, we need to understand this information. We need to collect data around what are the available maintenance techniques, what is the cost associated with it, and what is the expected increase in performance if a given maintenance technique is adopted. This is an example for roads, but more or less all the infrastructures follow similar performance curves, and the maintenance techniques can be represented as preventive maintenance, light rehabilitation, heavy rehabilitation, routine maintenance, and so on. Now, let us move on to the next set of data which needs to be collected. Once we have the information about different maintenance techniques, we also need to develop an understanding of what is the total budget available. If you see this particular chart here, we had seen that once we have the data, we need to do performance modeling. We saw that what are the different data points which can be collected for better performance modeling. Then we also saw that we need to develop different alternatives. Alternatives here mean different possibilities of maintenance. We have seen what information needs to be collected here. The next step is decision making. In order to do decision making, we need to understand the policies. Policies is part of the organizational focus. We have also seen what are goals. In addition to the vision, mission and goals, before we can do any decision making, we need to collect relevant information around what is the budget available. Unless we have an idea of how much money is available for maintenance and rehabilitation, we cannot do any informed decision making. So, the next set of data which needs to be collected is around budget. In order to understand the budget available with an organization, we try to assess what is the revenue the organization will be making from these infrastructure assets. So, we need to collect the relevant information. For example, say we are managing roads, then we can have information like tolls. We want to assess how much revenue will be generated from tolls. We also understand that there is a possibility that the state or the central government provides some money to the agency. So, we try to understand how much money will be received by the organization from some of these government organizations. There could also be other mechanisms like road cess, road tax and so on, which contributes to the revenue. So, we need to collect relevant information around this so that we understand what is the total revenue of the agency. Now, from this particular revenue, we subtract the following. The first is the estimates of planned M&R activities. There might be some M&R activities which are already planned, however, they are not paid yet. So, we subtract these from the total revenue which is available. Also, there can be other departments within the organization which will require money. So, we also subtract the budgets which we have received from other departments. Also, sometimes there can be some past adjustments and contingency costs. So, finally, the budget available can be given as the total revenue of the organization which is available for maintenance and rehabilitation minus summation of all costs. So, as far as data is concerned, we need to collect relevant data around revenue, estimates of planned activities, budget requirement of other departments, as well as if there is any past adjustment. The idea is simple, that total revenue minus total cost is the amount which is available for maintenance and rehabilitation. Moving on, the next set of data which needs to be collected is around assets performance. We have seen that we need to collect some information to assess how performance will vary over time. But the more important question is, how will you measure performance? What parameter will you use for measuring performance? Oftentimes, there will be more than one parameter to assess performance. So, within asset performance, we try to collect data of all the mechanisms for assessing performance of an asset. Assets performance can be measured or assessed for different aspects. For example, say you have a hostel building. For that hostel building, you can say that I will measure performance based on some regulatory and technical parameters. For example, you can say that does the hostel building meet legal requirements? If so, then it meets our performance requirement. Does it meet the safety standards? Does it meet quality standards? Can we say that the building is reliable? All these could be one set of methods to assess performance of a building. Then you could say that there has to be some environmental considerations. You want that the building should have good air quality both inside as well as outside. You can say that the performance of the building should be environmentally acceptable. You can say the energy conservation in the building should not be very high. Or you could say that we have a performance goal of sustainability. Within sustainability, there are all the three aspects of economics, environment and equity. So, you want that sustainability could be a performance measure. Then if you are staying in that building, you might have other priorities. You might say that as a user who is staying in that building, I want everything should be cost effective. That could be other way of assessing performance. That is the cost within the budget? Or you could say I want good aesthetics. I want everything around me should look good. Also, you could say that as long as the building is fulfilling my requirements, then my performance is met. Or if it is available whenever I need it, then I would say that yes, this building meets my performance. Also, in case something goes bad, can the infrastructure or the building be maintained? Can I maintain it within time? If so, I could say that yes, this building meets my performance. So, we have seen that there are so many different methods of assessing performance of an infrastructure. There is no correct answer to this. One could easily say that there will be always 5 to 6 different performance measures which needs to be assessed to understand the performance of an infrastructure. Regulatory requirements, technical requirements, user requirements, environmental requirements are just a few set of requirements. A user might have his or her own infrastructure requirements and would expect that the infrastructure should meet its performance requirements. For example, if there is a transportation network, a user might say that the total travel time to work should not be greater than 30 minutes. Now, that becomes a performance requirement for that user. An agency might say that we want to ensure that the cost of travel for a person should not be above 5% of what they earn. This can again become a performance measure. So, there are several methods to assess performance, and this is where infrastructure asset management becomes tricky. In one of the subsequent weeks, we will be discussing about different performance measures in detail. We will talk about the aspects of sustainability, resilience, performance, reliability, and so on. I will discuss about these in detail later. For the time being, let us understand that based on the performance measures which are available, we need to collect a lot of data. Also, in the last lecture, we had seen that any performance measure we have, it should have some of these characteristics. It should be measurable, well defined, it should be reliable, it should be accurate, it should be robust, and it should be complete. So, we have discussed that there are several performance measures possible. At the same time, we want a measure which we select should be such that it is robust, complete, accurate, measurable, and reliable. So, now coming back to our discussion on data requirements, the last aspect which needs to be covered is around total costs. We have discussed about budget, we have discussed about costs of maintenance, but in addition to these costs, there are some other costs associated with infrastructure asset maintenance. Let us talk about them in detail. Different costs associated with infrastructure asset management include agency costs, user cost, as well as social cost. Often there is trade-offs between these costs. That is, if one cost increases, then the other goes down. Now, agency cost is what we have already talked about. This is the cost which will be incurred by the organization which is doing the maintenance. So, if there is a highway agency which is doing road maintenance, they will carry out different M&R techniques. Each of these will have a cost. All these costs are agency costs. In addition to construction costs, there can be administration costs as well as other indirect costs to run the agency. All these are part of the agency costs. In addition to agency costs, in case of an infrastructure, there is a user cost. Since most of the infrastructure is developed for the public, oftentimes the users of an infrastructure are the public who will be using it. Now, let us see an example to understand what is user cost. Say your home is here at point A and your office is here at point B, and you need to travel from A to B daily for work. Now, road section AB is developed and maintained by the highway agency. Imagine the quality of road is poor. A road is in poor quality would mean that it will take more time for you to travel from A to B. Also, your vehicle will suffer more wear and tear. Also, you might have higher fuel expenses. You might have mental fatigue and so on. So, all these costs become the user costs. We say that whenever a road or an infrastructure is not maintained on time, there is a user cost associated with it. Now, here when I say there is a trade-off, I hope the idea is clear that as an agency, if I have to do any maintenance, I have to incur some costs. So, the agency costs will go higher, but if I do maintenance at the right time, the user costs will go down. So, when I say there is a trade-off, so that is why I said that some of these costs are indirectly related to each other. Another aspect of user cost is as follows. Let us assume the same example where you have to travel from A to B and the road has been blocked for maintenance activities. So, say for 3 months this road is blocked. Now, you might have to take a different route to travel from A to B. This might be longer. So, now for these 3 months you will incur some extra costs. So, again this is part of user costs. So, user costs includes the cost which the user has to incur if there is a maintenance going on and he is not able to use the facility. Also, it includes costs which are incurred if the infrastructure is in poor condition. In addition to agency cost and user cost, there is a third component which is around social cost. It is possible that there are social implications of an infrastructure, and that is the only road which connects the community to the city. Now, if that particular road is under construction or is in poor condition, it has socio-economic impacts. Say there is a community which is not well connected to the city. Obviously, it will have a social cost associated with it because there will be low socio-economic development in a region. So, this is another way of looking at costs, that what are the socio-economic benefits or socio-economic costs of our infrastructure. So, again as data is concerned, we need to collect data not just about the agency cost, we need to understand the data around user costs as well as the social costs. Now, in summary, we have understood that data is key for infrastructure asset management, and we also saw that we need to collect data for different aspects, right from organizational focus to budget available to assets performance and the total cost. Now, one important question here is, how do we decide what data should we collect? We cannot collect all the data because it will be too costly. So, in the next lecture, I will be discussing about different aspects of how do you go about prioritizing data collection, how do you decide what information or data is more important, and how do you collect it economically. Now, here are some of the references which you can use to dive deeper into these concepts. With that, I end this lecture here. Thanks for listening. Thank you.